I'm the principal engineer at Cambrian. The next 10 minutes, I will be trying to explain what we like from Ethereum. And then the thing that's like is a very tiny design choice in the EVM, and that exposure turns into a multi-billion dollar ecosystem. But I believe the potential of that tiny design choice is not realized yet. There's a huge gap, and we call it the intelligence gap. So at Cambrian, we are trying to solve that problem, the intelligence gap. That's right. So I will start by the idea, the tiny EVM choice. The control theory, basically explains what is observability. That's that if you can get the most of the system state out of its outputs, actually it is called observability. So I believe Ethereum didn't just do the execution part, optimizing the execution part. Actually, it's also optimized the exposure. So what is it? Is basically we have some very low level opcodes called logs, okay, log 0 to log 4, which is based for the solidity events. It's like whenever you do a swap, whenever you change a liquidity, actually you emit an event in the solidity contracts. But it makes it so easy that easily other parts like indexers, analytics, aggregators can easily watch it and collect the data. There is another example. I'm not saying that Solana is bad, but there's a difference, because actually if you want to have that state, like how much swap has done, what is the state of the liquidity pool, you need to go really in deep. You need to find out the instructions. There are some specialized log strings. Even I have seen ZK compressed data states inside the Solana. So you need to go deeper, and it's not easy to integrate. So that difference really matters, because when the integration is easy, the other ecosystems can basically do what you cannot do by yourself, okay? So there's the proof of it, by the way, with numbers. So probably most of you know Uniswap v3. Basically, Uniswap built the liquidity pool idea. If you ask me, it's the greatest thing that's done in EVM. The idea is you basically lock some tokens and people come and do the swap. But it seems like basic, but Uniswap also designed their exposure really well, their state really well. So others can come in and build what is not built inside the Uniswap system. And one of them is, which I worked for a very few weeks, is an aggregator, Odos. They just watch the state, know which liquidity pools have enough liquidity to do the swap, and create a, I'm from an industrial engineering background, create a really great solution to traveling salesman problem. Actually, you try to find the best path, okay? Usually, if you go for other aggregators, they have one hop or two hop. By hop, I mean you go for one liquidity pool to another, then you finish the swap. But due to the exposure of the liquidity pools, Odos has the capability to do it like 10 or 12 times. And it generated $40 billion volume in the first year over Uniswap. So as you see, this observability bring in a huge exposure, and that exposure turn into a huge volume. But there is a problem, there's a but in it. Why? Because this data, which we call event data, is not enough for generating intelligence. By intelligence, your protocol cannot decide on it. Why? Because it needs historic data. Like whenever you want to have intelligence, like analytics, it's nearly impossible to execute it. So it creates a huge gap. If you ask me, we call it like basically intelligence gap. So I will try to explain it in a very simple example. So in the left side, you see that someone borrowed 10 ETH, okay? So this data can be used by liquidity pools, but whenever you want to have something like, is the market safe to do some, let's say, lending or thing based on the idea, You can't do it because why? If you want to do it on chain, you will spend thousands of gas. Basically, you will lost it. It will kill it. And if you want to go off chain, which is oracles, yeah, now you lost the trust idea because the oracles, you're basically looking for an AWS Lambda or a centralized database. So in Cambrian, we really want to solve this problem. We have been working for a year. So I will try to explain what we have finished. I feel like everybody's liking animations. So the idea is like, we don't want to introduce a new oracle. Basically, we want to reinvent the stack as much as we can. I'm coming from like, I'm an industry engineer, but I've worked for more than 2 decades on databases, how quorums work, how you have a cluster of data. So we understood that we need to have something called verifiable data network. So each node is like collecting the intelligence, the data, and agree on that they have the same data. This is the basic idea a blockchain has. So we introduce that trust back to the analytics. So the next thing is we understood that the idea about certainty, the trust, differ from application to application. If you are doing swaps in few dollars, or let's say your volume is small, you don't need to run all the network, like thousands of nodes, to get into a quorum for a number. You basically request, let's say 2 or 3 is more than enough. This creates a cost efficiency. So it is not like you ask the network a data and then we basically charge you thousands. You can easily say, oh, okay, I'm happy with 2 or 3, or I'm happy with, like, we also introduced slashing, saying that, okay, I want to run this, I don't want to say query, I don't want to say data. I basically, it's intelligence. I want to have this intelligence by slashing, for example. The next thing is, it is not here, but the idea is we understood that like the protocols is not just on-chain. They have off-chain components, like web UIs, agents, even they have their own REST APIs. So we bring in standard API, the Web2, the old, but also it helps you to get fast data from the system without quorum. And lastly, at day 0, we understood that we shouldn't be doing anything for the, let's say, developers to learn everything inside this network, how to create this pipeline. So we try to achieve this with agents. So the next 2 minutes, I'm going to show this as a demo that I recorded. So this is the VS Code with Clouded. So I ask it to implement a full under-collateralized lending protocol. The problem about under-collateralized lending protocol is like you have less collateral for the same amount of money that's borrowed. And you need to create some risk calculation out of it based on whatever you have. And funny enough, actually, if you ask like this, it will create the risk calculation based on the amount you borrow, which is like over collateralized. So it's useless. It's static. It's like 80% of the LTV or something. So I come up with another idea. Wow, it goes really fast. I come up with a new formula, which is called Pulse, which is based on historic data. I need to look at this one. It's based on, I'm not the risk actuary, so it's based on frequency, severity, velocity, and concentration. So I ask it to be implemented to Cambrian. So the agent, our Cambrian agent, which can understand the formulation and generate a pipeline, data pipeline for it, and create the required changes inside the protocol. The last one is like, as you see, the quorum, like especially when you implement this, is initially implemented by 1. So I wanted to have at least 2 data nodes to execute this query or data or intelligence. So it updates and finished it. This is the language we try to build that can extract that information. And finally, actually, I want to bind this to the web UI. A user can get in and do the lending. So this is the output. The result, we basically copied from Morpho. Sorry for that, Morpho guys. So whenever you connect your wallet, actually, as you see, the pulse risk calculation is directly there. Yep. So this is the end. And lastly, thank you. The idea about you are not alone. We want to show you that the exposure you create in your protocols can turn into multi-billion-dollar projects. So you are not alone. Please design its structure and keep in mind that that exposure will help you gather more growth. And the next one is, till now, the intelligence part is missing in on-chain execution. So you're not alone. We basically bring it with Cambrian. Thank you. That's it. Wow. Any questions?
Yeah, thank you for the presentation. I actually wanted to ask, what do you think of verifiable logs, ERC, which seems to be achieving pretty much the same goal, just on the like an base layer of the network?
So verifiable logs is like basically while I was working graph, actually, I've seen them. It is some part of it, basically. But when you build over it, that's the most important part. You need to execute it. You need to calculate the numbers out of that log. Even you keep it in your protocol. The problem here is if you calculate a huge average, weighted average. Have you ever seen the numbers? Actually, let's go for a Uniswap USDC BTC pool, okay? It's like millions. So even calculated per log will cost too much. Another idea is sometimes you can't do the M1 plus state. That is something like, for example, summation is something like this. So you got the sum till now. So then the new log will introduce another sum. Okay, you can optimize this gas, but you can't optimize weighted average or standard deviation. And also the intelligence about like this, like usually you also introduce some external factors. This is not just EVM events. This is something like states, instructions, and maybe an exchange rate that you trust in your protocol. So you need to introduce it. Yeah, it will also act like an oracle. So I hope it answers your question. Probably the missing key when I gave access to ChatGPT or Gemini, like if you are an investor or a developer, what would be your question is the black box. I didn't explain this. The black box is like basically we materialize the data. The difference is usually when you go for an oracle, they will execute the query, which will create a huge delay. The summation, the average. So we materialize it per block. That is the idea. So your data will be always available. It is not based on your query. It's not based on your request. That's it. Thank you.